In this lesson, we'll set up a multi-axis contour toolpath. After completing this lesson, you'll be able to create a taper mill, modify tool parameters, and create a multi-axis contour toolpath. In Fusion 360, we're going to start with the supplied dataset, multi-axis contour. I do want to note that this is the exact same dataset that we were working on the previous lesson. So if you want to carry on with your own dataset, if you've made any adjustments to what we've done, feel free to carry on with your own dataset, or you can upload this one if you had any difficulty. The next thing that we want to explore is going to be a multi-axis contour. So far we've talked about 3+2 positioning operations, where we use things like a 2D contour, drilling operations, or even 3D pocket clearing and adaptive clearing. These operations all worked in the same manner as they do in traditional 2.5 and 3-axis machining. However, we simply changed the position based on the orientation of the part in a 5-axis mill. What we want to explore now is in the multi-axis section, something called multi-axis contour. This strategy will allow us to use the tip of a tool given a contact curve. We're going to be exploring this on our multi-axis part, this link, which is not always the greatest example, but it'll help us explore various things like linking parameters, lead in and lead out, as well as the lead and lag, or the angle of the tool in relation to our selection. So when we take a look at this, the default tool orientation is going to be normal to the surface or the selected, in this case, contour. So we'll be able to get a good idea what that actually means before we try to apply it in 3 axes. So we're going to get started by selecting multi-axis contour. It's important to note that multi-axis contour only works with certain kinds of tools. It won't work with all tools. For example, if you tried to use a chamfer mill, it won't allow it to work. So to get started, we want to begin by creating a brand new tool. So inside of our document in our multi-axis contour, we're going to select the plus icon to create a new tool. The type of tool that we want to create for this is going to be a tapered mill. So we'll select taper mill and move on to all the rest of the parameters. I'm going to start it in the post processor section, changing this to tool number 9. I want to make sure that I have that data, and then I'm going to go back and change the various parameters of the cutter. So right now the cutter comes in the inch unit system with 3 flutes and some various parameters. You'll notice that it's set as a bull nose. A bull nose means that it's flat on the bottom, similar to a flat end mill, but it has a radius or rounded transition into the sides of the tool. So the difference between a tapered mill and a bull nose is simply that the sides are tapered instead of being in the same axis of the tool. So now that we have the general shape of the tool defined, we want to start to modify the various parameters. Now some of these will cause errors as we begin to define them, but let's go through all of them, first setting the diameter at 0.05. The shaft diameter is going to be 0.2. The overall length is going to be 2 inches. The length below holder, we're not going to worry about just yet, but we are going to set that at 1.25 as just a general value for right now. The shoulder length, I'm going to set to 0.625. Notice that it gives me an error that the shoulder length must be larger than the flute length. The flute length is going to be 0.425. The corner radius will be 0.02. And right now, the taper angle is set to 5 degrees, and I'm going to go ahead and leave that value. So notice we have a preview on the screen showing us exactly what this tool is going to look like. We're going to go back to our general parameters, and in the description, we're simply going to call this a taper mill. I don't have any vendor data or product ID, but we're just going to have that general description so that we can see it when we're looking inside of our tool library. Now that we have that new tool created, I'll go ahead and select it. I didn't define a holder, so all we're seeing is the tool itself. In general, that is going to be problematic. You always want to make sure that you're representing the actual holder, especially in multi-axes, to make sure that we're not colliding with any geometry. However, in this instance, I really want to focus on some of the parameters of a multi-axis contour. And I think just having the tool is going to help us better understand that. Right now, with this defined, we're going to move our way into our geometry section. Inside of here, we want it to follow the inside contour of this pocket. This is not generally where you would expect to use a multi-axis contour, but again, the purpose of this is to better understand what the tool parameters are doing. So if we go to our passes section, notice that in the passes section, we have a top section here, which allows us to determine what happens if the trim is impossible, or we can fail when impossible, or we can turn when impossible. We can determine the compensation, whether we're centered on our selection or to the left or right. We can repeat a finish pass. If we determine if it's a left or a right offset for the compensation, then we can modify some of the other parameters like the axial offset. Right now, I'm going to leave all these as default, and we'll simply say OK, and we'll see what this does. From here, I'm going to simulate and just take a look at the results as to what the tool is actually doing. You'll notice right away that the tool is tilted. And if we begin playing this and slow it down, you can see that the tool is staying in between the two surfaces. Now remember, the default orientation is normal or perpendicular to the selected surface the contour is on. Because our edge is between a 90-degree corner, it's showing it up at 45 degrees. So as it rolls around the corner, you can see that it's at 45 degrees, and there is a default value that's controlling how that tool is moving. So you'll notice that the maximum tool axis sweep is 5 degrees. It can tilt between 0 and 180, and this generally happens based on your selection. But then we have these other values which are all set to 0. The forward tilt, the sideways tilt, these are all parameters that we can modify based on how we want the tool to drag along that contour. For right now, we're going to say OK, go back to a home view, and we want to save this, but we're going to explore these operations a bit more to get a better understanding of how we can adjust them. So make sure that you do save it before moving on to the next step.